Okay, so the question here, which is a Newton Alta um, problem, section 1.3, it says this: a reflecting pool is shaped like a right triangle. So remember um, what a reflection pool is. So I just Google things if you don't know the meaning of it. So when you Google, let me see if I can get it. So when you Google reflection pool, this is what shows up. All right, so these are examples of reflection pools right here. Just think about your by a pool and you can see your reflection, right? But this one is just saying that it's in the shape of a right triangle. So meaning that you have a reflection pool that is the shape of a right triangle, looking something like this. Okay? And remember, a right triangle, right here, I'm going to draw the right angle. A right triangle, you have two legs. So the side that's opposite the right angle, remember, that's called the hypotenuse. Okay, that's called the hypotenuse. And the other two sides are called the legs. Okay, so just put singular leg. So these are called legs. All right, and then you're told in this problem, you're told that one of the legs lies along the wall of the building. So let's say this is my building right here. Okay, so this is my building right here, and then this is the wall of the building. So this reflection pool, which is the shape of a right triangle, one of the legs, one of the sides, is adjacent to this building. All right, and it says this: the hypotenuse. Remember, we talked about the hypotenuse. That's this right here. The hypotenuse is 9 feet longer than the side along the building. So here's the side along the building. The hypotenuse is 9 feet longer than this side. You're also told that the third side is 7 feet longer. So this side here is 7 feet longer than the side along the building. So the hypotenuse and the leg, this relationship and this relationship depends on what this side is. You don't know what those sides are, right? You're trying to find those lengths of the sides. So mathematically, what you're going to do is you're going to relate those in terms of expressions. So you have the leg along the building, right, which we call the side. You have the other side, right, and then you have the hypotenuse. And what you want to do is you want to represent all of these unknowns using variables. And so notice that this hypotenuse and this side here, this leg, depends on what this is, both of them. So what we're going to do is we're going to let this be x. Let the side along the building, adjacent to the building, be x feet. So this will be x feet. Okay? So the side along the building. The other side, remember what you're told, the other side, the third side right here, the other side is 7 feet longer. So remember, 7 feet longer means 7 plus, right? 7 plus. So 7 plus the side along the leg, along the building. Well, the side along the building is x feet, isn't it? Isn't that what we called it? So that means that the third side here, this leg, this other side, is 7 plus x. Now remember, addition is commutative. The order in which you add does not matter. So someone else could have said x plus 7. X7 plus x is the same as x plus 7. Remember, this means 7 feet more than the side along the building. Then you're told something about the hypotenuse. Well, the hypotenuse right here, the hypotenuse is 9 feet longer than that side along the building. Well, if the side along the building is x, then the hypotenuse then would be x plus 9, right? So this is your hypotenuse, and this is the other side, which we said was x plus 7. Okay, so now I have, I'm going to go ahead and write it here, x plus 9. So now I have the expressions for each of those sides, the two legs and the hypotenuse. Now remember, Pythagorean's theorem says this. So remember Pythagorean's theorem. So this is A, this is B, and this is C. there's a relationship between those three sides of a right triangle. So the relationship is this. If you square the legs just like this and add them up, so a squared plus b squared, the relationship is that this will always equal, a squared plus b squared will always equal the hypotenuse squared. That's what that is. So that's Pythagorean's theorem. All right, Pythagorean's theorem. Okay, now we're going to use Pythagorean's theorem to help us determine the length of all of those sides. And so we're going to take all of this, I'm going to substitute it into this formula, into Pythagorean's theorem. All right? So remember, Pythagorean's theorem says this leg squared plus this leg squared equals the hypotenuse squared. All right, so let's go ahead and set it up. So here's how you're going to set it up. All right, so this leg is x, right? So according to Pythagorean's theorem, I'm going to take that leg and I'm going to square it. I'm going to say plus, then I'm going to take the other leg, x plus 7, and do the same thing. Now, remember, you got to, since this is more than one term, then in this case it's a binomial, you have to put this in parentheses because this whole thing is being squared. Then you're going to say, all right, well, that's going to equal the hypotenuse squared. Well, the hypotenuse is x plus 9. So I've got to square that. Notice the same thing. Put that in parentheses. And so there's your setup. Now, you got to do some more work, though, because remember, you got to solve for x. So you got to do some more work. So what you need to do is notice that I am squaring a binomial, right? So let's go ahead and square that binomial. Let's get rid of those parentheses. So let's think about what x plus 7 squared means. X plus 7 squared means x plus 7 times itself. And notice I'm multiplying two binomials. So when I multiply two binomials, I can use the FOIL method. And so remember, the FOIL method means first, outer, inner, last. So when I look at these two binomials that I'm multiplying together, I'm going to use the FOIL method. And so the first means this. First term times first term. So x times x is x squared. O means outer. So the outer terms, right here, the outer terms, the terms on the outside, x times 7 is 7x, so plus 7x. Then the inner terms, the inside terms, that's 7 times x again. So 7 times x is another 7x. So remember, whenever you square a binomial, the outer and the inner always going to be the same if you're squaring a binomial. Then the last means I'm going to take the terms on the last terms of each binomial. I'm going to multiply them. 7 times 7 is 49. All right, then you got to combine like terms. So remember, these two are like terms right here. They both contain the variable x to the first. Okay, this is x squared. This is x to the first. This is x to the first, and this is your constant. So these two terms here are like terms. So 7x plus 7x is 14x. So x squared plus 14x plus 49. So all of this work just gave us this right here. So let's go ahead and rewrite it. So I have x squared plus, and then this right here is this trinomial, x squared plus 14x plus 49 equal. Now we can do the same thing with this. We have to square this binomial. So if I do that, remember x plus 9 squared means x plus 9 times itself. So now to multiply two binomials, I'm going to use the FOIL method again. So we have x times x is x squared. The outer, x times 9 is 9x. The outer and the inner, remember, are going to be the same since I'm squaring a binomial. And then the last, 9 times 9 is 81. Combining like terms, so x to the first, those are like terms. I get x squared plus 81x. Plus 18x, and then plus 81. So that trinomial is going to be on this side of the equal sign. So I get x squared plus 18x plus 81. Okay, now what you have here is a quadratic equation. quadratic equation. So we got to solve this quadratic equation. To solve a quadratic equation, we need to first of all write it in standard form. And standard form means you can bring everything to one side and have 0 on the other side. So before I do that, let's go ahead and combine like terms on this side. X squared plus x squared is 2x squared. So I have 2x squared plus 14x plus 49. So that's this right here. These two terms are like terms because the variables have the same exponent. 2. So those are like terms. X squared, 1x squared plus a 1x squared is 2x squared. And then 14x plus 49 equal. And then I'm just going to rewrite this over because there are no like terms there. Okay, now remember we got to write this quadratic equation in standard form, meaning I want 0 on the other side. So what you're going to do is you're going to bring every term here, all those 3 terms, to this side. And what most students do is they say, well, if this is x squared, I'm going to go ahead and subtract x squared. But what you do to one side, you have to do to the other. And always align your like terms. So notice I'll put in subtract x squared there. So subtract x squared, subtract x squared. What you do to one side, you must do to the other. Then we're going to subtract 18x. See, that's remember the whole idea is to get 0 here. So notice I am x squared minus x squared 0 in it. 18x minus 18x is 0. But remember, what you do to one side, you have to do to the other. So if you subtract 18x here, you have to subtract 18x here. And I'm going to go ahead and combine like terms. I'm sorry, align like terms. So minus 18x. And as I put all the x's on each other. So x squareds on each other. The x's are on each other. And then you're going to subtract 81, just like this. Okay, what you do one side, you do the other. You put the constants together. So now we're going to add these up, combine like terms. So 2x squared minus 1x squared is x squared. 14x minus 18x is a negative 5x. I'm sorry, negative 4x. And then 49, use your calculator if you have to. And so remember, in this course, I asked you to purchase the TI-30X. All right, so 49 minus 81 equals, remember, you cannot use a graphing calculator, so you must not be using a graphing calculator. It must be a scientific calculator, any scientific calculator, but the one I use in the videos is the TI-30X. So you get minus 32 here. And then that's going to equal, remember, all this is 0. 0 plus 0 plus 0 is 0. So now notice it is in standard form. Now what you're going to do is, for us, it's going to be factorable. So now we're going to factor this trinomial. So we're going to factor this 2 binomials. And then we remember this is trial and error. So that's one of the things that you learned in, you may remember you learned it before. You may have forgotten all about it. You may have forgotten you learned it. You may say, well, I never did learn it in school. But there is, if you go back to the Canvas course, remember I told you on that first video I sent you at the beginning of the semester, there's a factoring set of videos. So go ahead and look at those. But basically, you're going to use reverse FOIL. Remember the FOIL? You're going to use reverse FOIL. So you're going to say, what times what is x squared? Well, it's just x times x. Okay? Now let's go to the last. So 32. So you want 2 numbers whose product is 32. So for example, 8 times 4, 8 times 4 is 32, right? And then 16 times 2, and then 32 times 1, and so on, right? Okay. Now, this doesn't always work, but the approach here would always try to choose, the first thing you ought to choose is to choose the numbers here that are closer together in the number line. So 8 and 4 is closer than 16 and 2 on the number line. So I'm going to put 8 here, does not matter for right now. You could put 8 here or 4 here, does not matter. Now, the last sign's negative. So remember, in order to get a negative 32, remember the last here of FOIL, in order to get a negative 32, this product to be negative, one has to be positive, the other one has to be negative. And notice that the middle sign's negative. See right here? So that means that if you look at the outer, which is 4x, and you look at the inner, which is 8x, then that means that the larger of these coefficients here has to be that middle sign. So that means that 8x has to be negative, and then 4x has to be positive. And so now you can see that this has to be negative, and this has to be positive. And so I'm just going to rewrite this over to get x minus 8 times x plus 4 is equal to 0. Okay? So now you want to solve this equation. Okay, so you're going to use what's called the zero factor property. So the zero factor property says that if you have two or more products whose product, two or more factors whose product is 0, in order for this product to be 0, one of these has to be 0. So either A is 0 or B is 0. So that means now, using this idea here, that means either this is 0 or this is 0, because that's the only way this product is 0. One of them has to be 0. So then all you do now is set each of those equal to 0, just like this. And now notice I went from a quadratic equation to two linear equations. So then I get x equal 8 and then x equal negative 4. Okay? So these two values here are solutions to this quadratic. But remember, we are solving an application problem. And so when we solve an application problem, we got to make sure that these potential solutions or potential solutions to the application problem make sense. So in other words, let's look at negative 4, x equal negative 4. So remember the problem says you want to find the lengths of all three sides, right? Okay, so if we go back here, the length of the leg along the building is x feet. Well, if you look at this, one of my solutions to this quadratic equation is negative 4. Well, but remember, the length can never be negative. You can't have a side that says negative 4 feet, right? So that means then is that you cannot use this. You can't use this because length is not negative. So then that means I'm going to have to use this then. All right, so let me go ahead and rewrite this over. So remember the side along the building is x. And then the other side, remember right here, I'm getting it from here. You can get it from here, or you can get it from here. Then the other side's x plus 7. And then the hypotenuse is x plus 9. All right, so now what you're going to do is you're going to take this x and you're going to substitute it into these expressions. So if x is 8, and that means right here that the side along the building is 8 feet. Then the other side here would be 8 plus 7, which is what, 15 feet? And then the hypotenuse then would be 8 plus 9, which is 17 feet. And so then you're going to come back here, and there's there's the length of the three sides. And so in Newton Alta, you're going to come back here and you're going to say 8 feet, 15 feet, and then 17 feet. But notice all of this work right here, all of that work that had to be done to get the lengths of the three sides. All right, so application problems are difficult for students, but just do the best you can with them. Try and understand as much of this as possible, and the more mathematics you take, the easier this idea becomes. Okay, all right, but that's it. So that is how you're going to. This is how you would have solved this problem. All right. Well, don't forget about your proctoral practice quiz tomorrow, and the links are in Canvas, and you have to upload your work. So make sure you go back and review that other video I sent you.